The most American car you can buy right now wasn't made by Ford, wasn't made by Chevy, and it definitely wasn't made in Detroit. It rolled off an assembly line in Georgetown, Kentucky, and the company that built it is Japanese. 3 out of every 4 parts in a Toyota Camry originate in the United States. That's a higher American-made content than most vehicles coming out of General Motors, Ford, or Stellantis. And the factory that assembles it is the single largest Toyota manufacturing facility on the entire planet. 9 million square feet, 1,300 acres, nearly 10,000 workers showing up every single day in Scott County, Kentucky, a county that only has about 60,000 people total. One company employs roughly 1 in 6 residents of the entire county. That's not just a factory, that's an economy. And what happens inside those walls goes far beyond any headline you've ever read about it. Because this isn't a factory that builds one car. It builds a Camry, then a RAV4 hybrid, then a Lexus ES, a $45,000 luxury sedan, and then another Camry, all on the same line, one after another, without ever stopping the conveyor. A luxury vehicle and a family sedan, sharing the exact same floor space, the exact same workers, the exact same production sequence. We're going inside today, all of it. Georgetown, Kentucky, 1986. A Japanese automaker chose a piece of farmland in the bluegrass state and announced it was going to build something that had never existed on American soil before. A wholly owned Toyota manufacturing plant. Not a joint venture with an American partner. Not a factory managed from a distance. A full Toyota operation built from scratch in the American heartland. The opening investment was $1.1 billion in $1,986. At the time, that was the largest single foreign investment in U.S. manufacturing history. Toyota didn't just buy land and pour a foundation. They built a community. They recruited workers from across Kentucky, sent many of them to Japan for training, and began constructing a facility that would take years to reach full capacity. May 26, 1988. The first vehicle assembled at what would become known as TMMK, Toyota Motor Manufacturing Kentucky, was a prototype 1989 model Camry. A 4-cylinder sedan. Nothing visually dramatic about it. But that car represented something enormous. It meant Toyota had committed, permanently and completely, to building its most important product on American soil. What came after that first Camry is one of the more remarkable stories in American industrial history. Since that prototype rolled off the line in 1988, more than 15 million vehicles have been assembled at Georgetown. 15 million. The plant also produces over 600,000 engines a year, and the Kentucky Powertrain facility has built more than 8 million engines in total. Those aren't just numbers. That's an output that rivals entire national industries. And the investment has never stopped. Toyota has put more than $8.5 billion into this facility over the decades. And in just the last 2 years, the commitments have accelerated sharply. A $922 million advanced paint facility opened in December 2024, the single largest dollar investment in Kentucky's history that year. A $1.3 billion commitment to battery electric vehicle infrastructure was announced in February 2024, then $204 million more for hybrid expansion in November 2025. Then just months later in March 2026, on the 40th anniversary of that original groundbreaking, Toyota announced another $800 million for a second BEV model and additional capacity expansion. Add it all together, and Toyota's total commitment to this single facility is approaching $11 billion. That happened while tariff uncertainty was rattling the entire automotive industry. While other companies were hedging, pausing expansion plans, waiting to see which way the political wind blew, Toyota announced $10 billion in U.S. manufacturing investment through 2030, with Georgetown at the center of it. But none of that tells you what actually happens inside. So let's go in. The process begins long before any car takes shape. It begins with flat steel. Raw steel coils arrive at Georgetown, each coil weighing thousands of pounds, and the first stop is the stamping facility. Massive hydraulic presses, some exerting pressure measured in thousands of tons, punch and shape those flat sheets into body panels. A hood, a door skin, a quarter panel, a roof. Each press cycle takes a fraction of a second. The speed is almost hard to believe when you're standing next to one of these machines. The steel arrives flat, and within seconds it has curves, creases, and the beginning of a recognizable automotive shape. Stamping dies, the precision machined steel tools that form the panels, are engineered to tolerances measured in thousandths of an inch. A die set for a Camry door and a die set for a RAV4 door are completely different tools. The stamping presses at Georgetown switch between them depending on the day's production mix, and the changeover process itself has been refined through decades of Kaizen, the Japanese principle of continuous incremental improvement, to take as little time as possible. From stamping, Those individual panels move to what the industry calls the body shop. That's where the car begins to look like a car. The body shop at Georgetown is a cathedral of orange sparks and robotic arms. Thousands of spot welds join panels together. Door frames locked to pillars, roof rails married to quarter panels, floor sections united with the firewall. Robots handle the majority of the welding, working with a precision and repeatability that human hands simply cannot match over the course of thousands of weld points per vehicle. But people are still everywhere. Quality technicians walk the line continuously, checking gaps, checking flushness, listening for sounds that shouldn't be there. A completed body in white, the industry term for the fully welded but unpainted shell, emerges from the body shop looking skeletal and industrial. No glass, no engine, no interior, just the steel skeleton of a vehicle. And at this point, before the car has even been painted, quality engineers are already measuring it against tolerances that would surprise most people. Gap and flush standards, the precision with which one panel meets another, are checked at multiple points across the body. A gap that's even a fraction of an inch off specification gets flagged and addressed before the car moves any further. Now comes the most dramatic phase of the entire manufacturing process: paint. The paint facility at Georgetown, the $922 million one that opened in December 2024, is an entirely different kind of engineering challenge. Before a single coat of color goes on, every body in white goes through an electro-position bath. The vehicle is completely submerged in a tank of primer solution, and an electrical charge draws the primer uniformly into every cavity, every seam, every area that a spray gun could never reach. It coats the inside of door pillars. It gets inside the rocker panels. Every hidden steel surface gets protected before any visible coating is applied. After the e-coat bath and an oven cure, the body moves through sealer application, rubber-based compounds injected into seams and cavities to prevent water intrusion, and then into the paint booths themselves. The new Georgetown paint process runs on waterborne paint chemistry throughout. Older automotive paint lines ran heavily on solvent-based coatings which released volatile organic compounds, VOCs, into the atmosphere in significant quantities. Switching to waterborne chemistry, combined with process improvements over more than a decade, cut VOC emissions per vehicle at Georgetown by 20% since 2012. The new facility pushes that further, cutting overall carbon from the paint process by 30% and saving 1.5 million gallons of water per year. Inside the booths, multiple layers build up in sequence. Base coat for color, clear coat for protection and gloss. Between each layer, cure stages in temperature-controlled ovens set the chemistry before the next coat is applied. The entire paint process for a single vehicle takes hours. The booths are climate-controlled to a precision you'd associate more with a laboratory than a factory floor, because temperature and humidity affect how paint atomizes, how it flows, and how it bonds to the surface underneath. After paint, the bodies look exactly like the cars you'd see on a dealer lot. And here is where they enter arguably the most sophisticated part of the entire operation: the final assembly line, specifically the K-Flex line. On most assembly lines, one model runs at a time. You run a week of Camrys, then you retool, then you run a week of RAV4s. Changing over a traditional line from one vehicle to another takes time, costs money, and creates gaps in output. Georgetown doesn't do that. The K-Flex line, Toyota's flexible mixed model production system, runs a Camry hybrid, then a RAV4 hybrid, then a Lexus ES350, then a Camry 4-cylinder, in continuous mixed sequence, on a single moving conveyor, without stopping, without slowing, without retooling. The sequence changes based on something called high junka, production leveling, where the order of vehicles on the line is deliberately mixed so that every station along the assembly line faces a level, predictable workload. Think about what that means in practice. Station 47, wherever it sits along the line, might need to install a door wiring harness. On a traditional line, that station does the same operation thousands of times in a row before the model changes. On the K-Flex line, Station 47 might see a Camry hybrid, then a RAV4 hybrid, then a Lexus ES, each one requiring a slightly different harness, a slightly different routing path, a different connector configuration, and the worker at that station has to execute all three versions back to back without error at line speed. Toyota solves this through two interlocking systems. The first is adaptable fixturing. The devices that hold and position a vehicle body during assembly use rotatable triangular bases. When a sedan body arrives, the fixture angles one way. When an SUV body arrives, it rotates to a different position. No manual intervention. No stopping the line. The fixture reconfigures itself as the body type changes. The second system is parts delivery. On a mixed model line, you can't just stock a bin of Camry door handles and another bin of RAV4 door handles and let workers grab whichever one they need. That leads to errors. Instead, Parts arrive at each station in the exact sequence they're needed. A Camry Hybrid is third in line on the conveyor, so the Camry Hybrid door handle arrives at station 47 as the third item in the parts delivery sequence. Parts and vehicles move in lockstep through the entire assembly hall. The logistics system that coordinates this across hundreds of stations simultaneously is as complex as any element of the physical manufacturing process. And then there's the Lexus. In 2015, Toyota began producing the Lexus ES350 and ES300 at Georgetown, the first Lexus ever assembled on American soil. And here's what makes that genuinely striking. There is no separate Lexus wing, no luxury enclave with different lighting and white-gloved inspectors. The Lexus ES rolls down the same conveyor as the Camry and the RAV4, in the same building, past the same workers. The question you have to ask is, how do you hold a luxury standard on a mass production line? The answer isn't a special room. The answer is 1.5 million hours of training. Before Lexus production launched at Georgetown, Toyota invested 1.5 million man-hours of team member preparation. Workers traveled to Japan, not for a week-long tour, for extended periods of hands-on training at Lexus facilities where the craft standards were developed. They learned gap and flush tolerances that are measurably tighter than Camry specifications. They learned interior fit tolerances, how a dashboard panel should seat against a door trim, how a leather surface should align with an adjacent hard panel, to a degree of precision that requires both measurement tools and trained eyes working together. They learned the Lexus standard not as a checklist, but as a sensibility. When a Lexus ES body comes down the line, team members certified on those Japanese standards handle the specific operations that define Lexus quality. Same physical space, same conveyor speed, a completely different quality layer applied through a cultural standard that lives in the workforce rather than the building. A $45,000 luxury sedan, assembled back-to-back with a $30,000 family car. No compromise on either one. That's the paradox at the center of Georgetown's production philosophy. And it only works because of decade after decade of workforce development that Toyota has poured into this facility. Now, let's talk about what happens when hybrid technology meets mass production. Georgetown has been integrating hybrid battery packs into vehicles since the early 2000s. When Toyota brought hybrid production to Kentucky, the technology was still new enough that most automotive engineers in America had never handled a high-voltage battery system outside of a laboratory. Georgetown's workers were trained on live high-voltage systems, on the safety protocols, on the assembly procedures for what is essentially a sophisticated electrochemical device being installed into a moving vehicle on a production line. The NiMH and lithium hybrid battery packs fitted to the Camry Hybrid and RAV4 Hybrid are installed during final assembly as single units, slid into position and connected to the vehicle's electrical architecture with a precision that the earlier generations of those workers had to learn entirely from scratch. That experience, 2 decades of high-voltage system integration on a mass production line, is exactly why Toyota is positioned to make the next transition without tearing the factory apart, because the next transition is already in motion. Later in 2026, Georgetown will begin producing the first American-built battery electric vehicle in Toyota's lineup, a 3-row electric Highlander SUV. A second unnamed BEV model follows after that. And here is the engineering challenge no other automaker has attempted at this scale. The K-Flex line is being adapted to build full battery electric vehicles alongside hybrid models and internal combustion vehicles simultaneously in mixed sequence. A BEV underbody is fundamentally different from an ICE or hybrid underbody. The floor of an electric vehicle integrates the battery pack as a structural element. The underbody is taller, heavier, and requires different installation sequencing than a conventional platform. Adapting a mixed model flexible line, one that was designed for sedans and crossovers that has been running for years, that is currently producing over 100,000 vehicles a year, to also accommodate BEV platforms without stopping production is a manufacturing engineering challenge on a different level than anything the industry has tried before. Toyota can attempt it for the same reason Georgetown can build a Lexus next to a Camry. The workforce, the systems, and the continuous improvement culture have been building toward exactly this kind of complexity for almost 4 decades, which brings us to the philosophy that underpins all of it, Kaizen. The Japanese word translates roughly to change for the better, but in a Toyota factory, it's better understood as a structured cultural practice of relentless, incremental improvement applied to every process, every day. Not just by managers, not just by engineers, by every person on the floor. The most visible expression of Kaizen at Georgetown is the andon cord. Running along the length of every assembly line section is a cord, or in modern versions a button, that any team member can pull at any moment to stop the line if they identify a quality issue or a process problem they can't resolve in the time a vehicle is at their station. And the line actually stops, not reluctantly, not after a supervisor approves the stop immediately. On most factory floors, stopping the line is treated as a failure, an emergency to be avoided at almost any cost. At Georgetown, a line stop is the designed response to a quality signal. The system is working correctly when that cord gets pulled. The end-on system at a Toyota plant triggers dozens of brief stops per day. Each stop is investigated, understood, and closed out. Each closure represents a small piece of learning that gets built into the process going forward. The cumulative effect of that over years is profound. VOC emissions per vehicle dropped 20% since 2012. Not through a single large capital investment, but through hundreds of small process improvements made by workers who spotted inefficiencies and had the means and the authority to propose solutions. A weekend initiative focused on steam system efficiency saved $1 million a year in energy and labor. Not a major retooling project, a weekend, a focused team, a specific problem, a solution that paid back permanently. What actually makes a factory like Georgetown hard to replicate isn't the machinery. The machinery can be copied. The building can be duplicated. The philosophy, the depth of it, the way it genuinely runs from the executive floor to the assembly floor, takes decades to build. And then there are the numbers that give all of this a direct personal dimension. The Camry is, right now, the best-selling new car in America. Not just the best-selling sedan, the best-selling new car, period. In the first quarter of 2026, Toyota sold 78,255 Camrys, an increase of 11.3% over the same period the year before. In a single 45-day stretch, 68,841 Camrys found new owners, 23 consecutive years, as America's best-selling sedan, nearly every one of them built in Georgetown. The RAV4, also assembled at Georgetown, tells a slightly different story right now. First quarter 2026 RAV4 sales were 59,869 units, down sharply from 115,402 the year before, a 48% drop. That sounds alarming until you understand what actually happened. There was no collapse in demand for the RAV4. The drop came entirely from a model year changeover supply constraint. The line literally paused its RAV4 production sequence to retool for the updated model. Supply dried up because the factory was transforming itself. Demand stayed exactly where it was. That's the RAV4's real story. Not a sales problem, but evidence that even at this scale, Georgetown was willing to interrupt output on one of its most popular vehicles to properly execute a model update. No half measures. No shipping an outdated vehicle to clear inventory while secretly running the new one. Full changeover, full commitment. Now step back from the production metrics and consider the economic footprint. Georgetown, Scott County, Kentucky, approximately 60,000 people. Toyota employs nearly 10,000 of them directly at TMMK. That's roughly 1 in 6 people in the entire county working for the same company. But direct employment is only the beginning of the economic story. Toyota works with more than 400 suppliers nationwide, more than 100 of them in Kentucky alone. The supply network that feeds Georgetown, the steel, the glass, the plastic components, the wiring harnesses, the seat assemblies generates employment across the state and across the country that multiplies the direct headcount many times over. In total, TMMK supports an estimated 30,000 jobs across Kentucky when you count direct workers, supplier employees, and the broader economic activity those incomes generate. 30,000 jobs anchored to a single facility in a single county. For a state of 4.5 million people, that's not a footnote in the economy. That's a pillar of it. And here's the detail that stops people mid-sentence when they hear it for the first time. The 75% American content figure on the Camry. That's verified by the National Highway Traffic Safety Administration, which is required by law to calculate and publish domestic content percentages for new vehicles sold in the United States, not a marketing claim. A federal measurement. And when you line it up against the NHTSA's published numbers for vehicles from Ford, General Motors, and Stellantis, many of which source significant portions of their content from Mexico and Canada, the Camry consistently comes out at or near the top of the list. A Japanese company built a Japanese brand's most important product on American soil, with American workers, using predominantly American parts, and made it the best-selling car in America for 23 years straight. Whatever your assumptions were about what American-made means, Georgetown makes you reconsider them. The 40-year journey from that $1.1 billion groundbreaking in 1986 to the $800 million anniversary investment announcement in March 2026 follows a straight line of escalating commitment, each generation of investment built on what came before. The original Camry plant became an engine facility, then a Camry and Avalon facility, then a multi-model flexible line, then the birthplace of American Lexus production, and now the launching point for Toyota's first American-built electric vehicle. Every transition required the workforce to absorb new complexity. Every transition was executed without the foundational production discipline collapsing under the added pressure. That track record is the credibility that lets Toyota announce a mixed-model BEV integration plan and be believed, because Georgetown has already proven, many times over, that it can absorb this kind of change. The factory floor never rests. Right now, somewhere in that 9 million square foot building in Scott County, a body shop robot is laying down its 400th weld of the shift. A paint line attendant is watching a Camry move through a cure oven at a temperature controlled to within a single degree. A team member is installing a hybrid battery pack into a RAV4 with the same precision as the first time they did it 5 years ago. And 2 bays down the line, a Lexus ES is coming through, and the team member who trained in Japan 3 years ago is already moving into position. Not an abstraction, happening right now, every day in Kentucky. So here's the question worth sitting with as we close out. Toyota announced $10 billion in U.S. manufacturing investment through 2030, not during a period of industrial confidence, but during peak tariff uncertainty, when the entire global automotive supply chain was recalculating its assumptions. Other automakers paused, hedged, waited. Toyota reached into its pocket and doubled down on American soil. What does it mean for the future of American manufacturing that the deepest long-term commitment to building cars in this country is coming from a Japanese company, one that arrived in Georgetown, Kentucky 40 years ago and never looked back? Drop your answer in the comments and tell me, do you own a Camry or a RAV4? Before watching this, did you know it was built in Kentucky? I'd genuinely like to know how many people driving American-made Toyotas realized that was exactly what they were doing. If this story hit differently than you expected, hit the like button. It helps more people find this video who probably need to see it. Share it with someone who still thinks the best American-made cars all come from Detroit. And subscribe if you want more, because next week we're going inside a facility where precision is measured in millionths of an inch and where a single production mistake can cost more than most people's houses. You're not going to want to miss that one. Georgetown, Kentucky built 15 million vehicles and counting. The 40th year is just getting started.